Okay, let's get started. Hello, everyone. Good morning. Hope everyone enjoyed that amazing keynote earlier. My name is Marc Prud'hommeaux, and I'm an independent iOS developer. I've been developing for iOS since the App Store first opened back in 2008. And before that, I've been programming Objective-C for a very long time. Before that, it was Java, and I've been writing code for about 30 years. So I've gotten around. So today I'm going to talk about Swift. As you probably have heard, Swift is the new programming language developed at Apple. It's designed to eventually slowly replace Objective-C. And it was released back in June for the first beta. And only a week and a half ago was it finally released to the general public, where you don't need to be an Apple developer in order to start using it. So it's available for free for anyone to download from the Mac App Store. And this is going to be an overview of the language. So we're going to start with some Swift. We're going to look at some FP, and then we're going to do some tweet and some HOF, and then we're going to bork. And hope everyone's following along. And then I'm going to leave a little bit of time for questions. I like to leave a fair amount of padding for questions. So if you do have questions during the talk, I do encourage you to please enter them into the GOTO app on your iOS device or on your Android. And then at the end, we'll aggregate them all together, and hopefully we can cover quite a few of them. All right, so flash poll. Who here is a programmer? Who here programs computers? Every one of you. Who here is an Objective-C programmer? Wow, probably about half. Who here is a C# programmer? About half. And Java, C++, C, Haskell. Yeah. I like the diminishing returns. Okay, that's pretty much as expected. So let's start out with a tweet. Now I'm pretty old. I've been programming computers for a while, and I admit I don't really understand what this tweet stuff is, but you know, somehow it's totally different from the twerk, because that requires a Snapchat, and it's all very confusing to me. But I thought, you know, I'm learning new things. I'll jump in and I'll try to learn about this tweet. And it seems pretty popular here because it appears that everyone going along on their bicycle at 40 miles an hour is doing it with their head down without wearing a helmet. So it seems to be all the rage in this town, in this country. So because I'm old and, you know, kind of out of touch, I write this in Objective-C. So the half of you that speak Objective-C recognize this, and the other half, you probably don't need to understand what it's doing because you will probably never write it. But you've got, you know, you've got your normal interface, and you've got your implementation, and they go in different files, and you need to keep those files in sync yourself. There's very little help, and you've got some ampersands, and you've got some square brackets, and so this is basically a little model of how you might do a tweet. So you have this tweet interface, and it holds a username and a body, and then down there you have a tweeter service, and the tweeter service will tweet your tweet, and it's got a singleton, and here's a little demo of how you use it. So that's Objective-C. Congratulations to all the people who've never learned it before. Now you know all you need to know, and it's kind of meh. The language has evolved over a quarter of a century, very, very slowly, and has sort of gotten out of touch with some of the trends in modern languages. So here is that same code in Swift. Hope you all got that. Now you all know Swift. So this is not a complete introduction to the Swift language. We're not going to get bogged too down into syntax and details and how exactly you do things. This is more talk on how Swift can change some of the ways that you decide to compose and write your apps or your software, your services. So to start out, let's think about what is the same in Swift as in Objective-C. Swift has classes just like Objective-C. It's not breaking out of the object-oriented paradigm. They consider it a multi-paradigm language. Has methods on those classes. It has protocols, which you know, C# and other people refer to as interfaces. Has extensions, which are categories, which don't have a good analogy in other language. Has you know, what they call functions, as methods on classes. Has a little bit of automatic memory management. It doesn't have full garbage collection, but it does have the same sort of advances in memory management using what's called automatic reference counting. And then it has closures, which in Objective-C were known as blocks. So all this, none of this stuff is new. It's all basically a one-to-one translation from the existing Objective-C toolset that half of you know and probably a little less love. So here are some small additions that Swift brings to Objective-C. You have these new things called structures. Structures are like classes, but they're different. They're value types. We can discuss the implications of that in a little bit. And you have namespaces, finally. You don't have to be like cavemen and prefix your classes with a couple of uppercase letters that you hope will remain unique throughout history and not conflict with anything else. You have constants. You have immutable constants, which helps for some working with some immutable data structure programming. You have operator overloading. A few of you from C++, I'm sure half of you hate it and half of you love it. And then you have interoperability with Objective-C. Swift does run in the same runtime as Objective-C, so it's not running on a virtual machine or in some sort of emulation layer. It is running the same process space as your existing apps, which allows you to, I wouldn't say seamlessly, but it does allow you to interoperate with your existing iOS code, so you can incrementally adopt Swift over time. And then there's the big additions. There's the things that basically don't exist at all in Objective-C or in some other languages. And these are the things that it really brings to the table in terms of how you can start thinking differently about how you write your software. So it has enumerations, and enumerations are not just regular enumerations. They're very powerful. They can have methods on them, and they can have associated objects, which coupled with a very sophisticated pattern matching specification allows you to do some very interesting things. You have optionals. Swift is very heavily leans towards trying to encourage you to not have nulls in your code anymore. Those of you who have ever experienced a null pointer exception, I don't know if anyone has. I've had a lot of null pointer exceptions, and they're rarely fun or expected. One way around that is to have non-nullability, and Swift really encourages that and forces you to explicitly declare your properties as being nullable. Has generics. All you C# programmers know and love it. It's a great addition to the language. It really allows you to really tighten up your code and really know what's going on. No more do you have a NS array where hopefully it holds all strings, but maybe there are some ints in there, and that's fun. Has automatic type inference. Again, C# people are familiar with this. Has a lot of built-in support for mutability along the lines of structs. Has tuples, which are sort of like struct light. We'll look at those for a second. And it has first-class functions. And first-class functions are the thing I'm going to concentrate on today, because first-class functions are the thing that allows you to really adopt some of the more functional paradigms in your development. So I breezed over this, but let's look really quickly at this bit of Swift code that is the equivalent of the Objective-C service that I wrote before that writes the tweet. So you have this struct, that's a tweet. For now, you can think of a struct as a class. This one's just holding some data. This one holds a username and a body for the tweet. That var means that can be changed. The let means it's immutable after you create it. And then you've got my tweeter service that I'm going to use to tweet the tweet. You've got a function that takes a parameter called tweet, and that is of type tweet. And then there's some magic that happens in that implementation. And then there's a singleton here. You can get your single tweeter service. And then here's a little example of how you might do it. You'll create your tweeter service. You'll get the shared service. You make your message, and you send out your tweet. And pretty cool. So you'll notice a few more things. There are no semicolons. There are no prefixing the strings with ampersands. There's the ASCII arrows are denoting return types. Generally speaking, type follows name, unlike, say, in Java, where the name where the type always precedes the name. And yeah, I mean, you can probably figure out basically all this stuff by glancing at it. As I say, you can pick up the language in almost no time. So let's think about our tweeter service, and let's think about how we might improve on it. And one of the things we notice is that there's no way to get any indication of whether the tweet succeeded or failed, because I guess these go out over the internet, and then sometimes things can go wrong with that. It's not completely robust. So we need to figure out how to do it. So we've got this function, and this function returns void because it has no feedback. So I'm say a CS 101 student, and I decide, I'll just have it return a Boolean. I'll have it say, okay, it will return true if the tweet succeeded and the tweet failed. And then you've got that running in your on your main thread, on your app, and they click the tweet button, and the whole thing hangs, and you have to start thinking, there's maybe a little more complexity to this problem. You typically don't want to use synchronous methods when you're working with things that might be slow and unpredictable, like network traffic. So, we think a little bit about, how might we go about doing this? And, C#, you probably use some of the nice async services. In Objective-C, you would have used the delegate pattern bad old days. And delegate pattern is basically you've got this protocol, which is like an interface, and that has various callbacks along the protocol that will be invoked as various things happen. Right now, we just have one that is returns whether or not the tweet was successful. And then on the service, you'd assign a delegate to it, and then you tweet it out, and then that delegate would get called back, and you'd know whether it worked or not. And then you can decide, what do you want to do with the user? Do you want to let them know if it if they want to retry it or if they want to give up or something. And you can do exactly the same thing in Swift. I mean, you can adopt these patterns in any language. You can have a set of delegate methods, callbacks that wind up getting called. So you can do all that. But in recent years, all of the mainstream languages have been getting functional features attached to them. In Java, it's lambdas, and Objective-C, it's blocks, and C# is closures. But they're all basically the same. They're all a deferred block of code execution. And they're very useful for especially things like asynchronous services, but also in breaking up your code into modular chunks. And this is functional programming, essentially. Functional programming is a style of programming. It's not a set of strict requirements. There are functional languages that have a set of strict requirements that vary a little bit depending on which academic person you're talking to. But one of the major prerequisites of a functional programming language is that functions are first-class objects. First-class objects means that they are on par with your ints, or on par with your strings, or on par with your own custom classes. They can be passed around. They can be manipulated. They can return other functions and things like that. So as I said, it's a style. So you wouldn't say Swift is a functional programming language, but you would say it allows and almost encourages you to adopt a functional style for how you would do things. So let's do a very simple thing that probably many of you would have immediately thought to do, which is that let's have our tweeter service instead accept a block, a closure that will be invoked once the tweet is complete. So in this case, the syntax for a closure is that it's a function that accepts a single parameter, a Boolean type, and then in this case returns void. So here's an example of how this might be used. You've got your tweeter service, and now you've got your new Boolean to void function parameter for the tweet. And then you've got this done function, and that's a variable, just like any other variable, and that's of type. This is just a single type. Parameter Boolean returns void. And then here we're assigning the variable to something. Success in, you're naming that parameter. I believe in C# you use equals arrow, which is better syntax, but they chose in. And then we do something here, successful and failed, and then we send out the tweet. So you can shorten this. There's a lot of mechanisms for compacting some of the things you do. They have a lot of useful shorthand. Here you're doing the same thing. You're attaching it inline into the invocation of the service. And then here you're being even more compact. If your last parameter of a function is itself a closure, then you can declare it out of line almost as if it were a flow control statement. So in addition, you don't have to name your parameters. You can just use this $0, which is the first parameter. Type inference lets you know that's going to be a Boolean. And then here we just use a ternary syntax. So this is basically doing the same thing. You're sending out a tweet, and you just print out whether or not it succeeds or fails. And this is a higher order function. Higher order function is merely a function that takes other functions. Same, in if you have an Objective-C function that accepts a block, that's a higher order function. If you have a C# method that accepts closure, then that's a higher order function. So the functional style of programming is about composing functions and transforming structures in order to accomplish a task. Let's think of some of the very popular higher order functions that people often talk about, especially in the functional world. And these are map, filter, and reduce that everyone knows and loves. in the functional world. It's not yet very commonly used in at least the world of Objective-C development. And these always sound a little bit highfalutin and abstract at first, but they're extremely simple. You could write each of these function implementations in a dozen or less lines of code, at least the map and the filter one. All map does, it takes a bunch of stuff and it turns it into an equivalent number of a bunch of other stuff. So it takes 10 stuffs and turns it into 10 other stuffs. Filter takes a bunch of stuffs, like 10 stuffs, and it turns it into 10 or less stuffs, but of the same kind. And then reduce sort of compacts down all the stuffs into a single thing in some customizable way. So that's a little bit abstract. So let's think about a application. I mean, we've written this really robust Twitter service, this model layer and this API layer. So actually, I'm learning a lot about how Twitter works and what you can do with it. So I'm thinking I might actually write an app. It'll be, I hear Twitter is a great platform for third-party developers to develop for. So I'm going to write my own Twitter client, and I'm going to ship it on the App Store, and it will be pretty great. So I'm going to be location specific. I'm going to target the Danish audience. So I've got my group of beta testers, and I've got one of the more famous Danes out there on the internet. His name is Hamlet, and testing out my app, and he's writing, to paraphrase some of his more famous things, he's sending out tweets. And then if it works, maybe he'll be, and maybe if it doesn't work, maybe he decides not to be. But that's a question for another day. So he's able to do this a lot, all day, every day, tweet out a bunch of other stuff, and he wants to expand that beta test group to some of his friends, so we can get a second line of beta testing. So we go to his very good friend Polonius, and Polonius is not known for being very succinct in his words, and here he's trying to send out a tweet, direct message to his son Laertes, who's about to depart for France, and he's got a lot of great advice that you've probably heard about, like neither borrow nor lender be, and I don't see why this won't work, but I'm fairly new to Twitter, and then this happens. So it turns out that Twitter limits you to 140 characters for messages that you send out on the internet, which is kind of nuts to me, because I thought the internet was getting faster, not slower, and things like that. But that's the process we have to work with. So now I'm thinking that maybe I'll do some locale-specific compression of tweets and send them out to reduced size than they were originally composed. So I don't actually know Danish, but Americans are known far and wide for having a great ability to learn and start speaking other languages. And I do know a little bit of Swedish, because when I was growing up, we had a great series of educational programs of a gentleman who would teach both the Swedish language and Swedish cooking. He was a fantastic resource. Are there any Swedes in the audience right now? I'm told on Wikipedia that Swedes get tired of Americans approaching them about the Swedish chef, but he's a very beloved character in our society. So, one of the main things that you learn from the Swedish chef is that most words in Swedish are actually a single word, are just bork. He says bork, bork, bork when he starts the process. He says bork, bork, bork at the end, or when something goes wrong. And so that gave me an idea. It seems like you could probably reduce everything down to bork. Now, I'm not dumb. I know Swedish is an entirely different language than Danish. So, I did a little bit of research, and I discovered there's a pretty close translation equivalent. So we've got bork. So armed with that degree, I spent like half of my research and development budget on coming up with this. So it's pretty good. I'm thinking I might get a patent. So let's look at some higher order functions with borking. So we've got our tweet body, and the tweet body is Polonius's long message, and we want to translate this using our new translation algorithm. So the first thing we want to do is we want to split it up into words. And we do a fairly naive splitting of it, where we say there's a built-in function in Swift called split, and it takes a bunch of stuff. Doesn't have to be a string, doesn't have to be any particular type. It just takes a thing, and then you have a closure callback that accepts the individual components of the thing, and then returns whether or not that should be considered a separator. So we're gonna use this to segment up the body into individual words. More succinctly, you can just say $0 is equal to quote quote, because using type inference, it will know what the type is. So that's pretty cool so far. We've got a bunch of words, pretty advanced NLP stuff right there. Now we want to reduce it down a little bit, because in my research I discovered that usually longer words are important ones, and you can just sort of drop off the shorter ones, because rarely are they. They're the ands and the thes and things like that. So we're going to filter it down. A filter, again, is reducing a list of stuff into a list of the same kind of less stuff, equal or less stuff. So here we are saying filter, and you pass in a parameter word. And the count elements is basically, in the terms of string, is saying how long is that string. And a word greater than 7 characters, we're gonna chuck out. And so this big words array is going to be the filtered out list of words that has 7 or less characters. Now here's the amazing part. We're gonna perform the translation right here, and we're gonna do that by saying map. And what map does, it takes a list of a bunch of stuff, and it turns it into a list of a bunch of other stuff of the same kind. This is where, say, like Google might, query, some sort of dictionary and use like context-sensitive translation of words and things like that. But they haven't done the kind of research that I did, where I've learned that every word is actually Bork. So I'm going to map all of these big words into Bork. And the last thing is the function that people sometimes have a little bit more difficulty with, which is reduce. In this case, reduce is going to just be combining everything back into a single string for me. But reduce, essentially all it does is it takes a list of stuff and it turns it into a single thing. It reduces it down. So in my reduction here, in the it's kind of small, but it is taking 2 strings and it's just appending them together. You can get more succinct by saying the combine function takes $0 plus $1. You get even more compact because in Swift functions, operators are functions. And so in the case of a operator that accepts, one type on the left and one type on the right, you can just swap that into a closure that accepts those 2 types of parameters. So what we do next is we compose the function as a series of operations. So the first thing we do is we bring it all together. We split it up into words. We filter it down. We filter out all the large words. We translate everything into Bork, and we turn it back into a single string. And then in this particular case, we are able to send out a tweet in the acceptable number of characters. We have 125 characters, and Polonius is able to send some very helpful advice to Laertes on the eve of his trip to France. And that's what it looks like. And I'm sure Laertes is going to be able to understand that and be able to make great use of all that wisdom that his father is sending out. So everyone here knows you could do exactly the same in any other language. They're not doing any magic that you couldn't do anywhere else. So for example, in Objective-C, here's how you might perform the same operation. You go through, 4 individual steps. You've got a lot of looping. You have a little bit of branching. You go through and you break up the word and things like that. So you could do it in simple Objective-C. You can make that a little more succinct if you're using some of the conveniences that COCO programmers learn. Like there's a built-in mechanism for splitting up strings based on a separator. There's a, you can pass a block to a filter, and you can reduce it down. So you can do this in Objective-C or any other language. But big difference is you can make this very succinct, and with a little bit of experience, extremely readable. You can glance over it and you can say, okay, what is this thing doing? The other thing that this is doing is that there is no alteration in state anywhere here. You're not changing any underlying data structures that you originally came into. You're not you're not directly creating any individual arrays and then modifying them and subtracting from them and having to mess around with state. And when you avoid having to create and manipulate state, you make your code much, much simpler. You wind up writing a lot less code. And with less code, less really is more. When you have less code, you have fewer bugs, you have fewer maintenance issues. It's easier to understand. It's just a lot more succinct. So when you're looking into adopting functional programming styles, one of the things you want to do is you want to think about, how can I write less code? How can I stop looping? How can I stop branching? How can I reduce my state manipulation that goes on within my program? And you'll find with map and reduce and filter, you can actually eliminate almost every loop that goes on in your code. You can really drop out just a ton of boilerplate that you might be having written over the years. So, in general, these sorts of paradigms have been working into all the modern languages, especially some of the more experimental languages that say run in the JVM, like Scala. C# is doing amazing things with closures and things like that. Everyone is getting hybrid functional features worked into their object-oriented languages. And Swift is certainly not unique in that regard, but it is a bit unique in that it's one of the first new languages designed for like industrial app development that has these concepts built in, sort of baked in from the very beginning. And that allows you to more fluently adopt some of these styles as you go along. So I should say that I'm not a paid Swift evangelist. I'm just a personal enthusiast who's happy to not have to write Objective-C very much anymore, if at all. And there are a few, rough edges. It is brand new, and there are bugs. There are especially bugs with some of the IDE integration with Xcode and things like that. So that can make it a little bit cumbersome to get up and running with at the very beginning. Bridging, as I mentioned before, it does run in the same process space as Objective-C and the other Cocoa libraries. And that is a fairly heroic achievement on their part, but a lot of these libraries have been developed over the past quarter century. They go way back to the era of Next Step and all the objects prefixed with NS. That's from the Next Step days back in the 80s. And that is old and tried and true code that's gotten pretty bulletproof over the years, but it is not idiomatically similar to Swift. You may have noticed in some of that Objective-C code that you have very long method names, whereas Swift errors on the side of terse method names. So some parts of that bridging can be a little bit cumbersome to work with. There's no more dynamic dispatch. One of the things that Objective-C people often like about their language is that it's extremely objective. It's extremely dynamic. You pass messages to objects rather than invoking methods, and you can you make heavy use of duck typing, and so you can have a type of an object, and you can just sort of pass a message that you don't necessarily know if it will receive or not, and maybe that can proxy that method somewhere else. It allows for a lot of power, but it also allows for a lot of danger. And it's a trade-off. Swift really has lost almost all of that. You can't do many of these things in Swift. They err on the side of getting to be having more strong typing and less kind of cowboy coding with some of the stuff that you can do in Objective-C. And the major shortcoming right now, in my view, is that there's just no built-in error handling. There's no exception handling. There's not even really documented best practices for how you should handle errors, and that makes dealing with error conditions a lot more cumbersome, especially in terms of when you have to interact with maybe someone else's Swift libraries, and more will be coming out. You need to think about how are you going to bridge your mechanism for error handling with their mechanism. I personally predict that that will change over time, but as of now, version 1.0 released a couple of weeks ago, there's no built-in solid error handling. So that's kind of a shortcoming of Swift right now. So with that, those are what I deem the shortcomings of the language, and I'd like to get to any questions that people might have in the audience. Either are there any questions entered in through the app? Yeah. Okay. Swift. I would answer pretty clearly. There are pros and cons. Right now, there's a ton. Like if you look at Stack Overflow or something, there's perhaps 10 million answers about Objective-C, and there's maybe 10 answers about Swift. So there is a much larger body of existent Objective-C wisdom and source code and example code and things like that out there. But I don't think that outweighs the benefits of learning Swift. First off, it's going to be a lot easier to learn. If you already know C# or something, Swift will be, you'll be up and running in a day. It's not a complex thing. The complex part of building an app isn't necessarily the language. It's all of the user, the frameworks that you work with that the platform provides. Android has this whole, massive set of things, and .NET has its whole, all of its components and how the frameworks work and things like that. And iOS has its own whole world of user interface components and mechanisms for finding your location, things like that. Those are the difficult parts of learning, and they're going to be the exact same learning curve either in Swift or Objective-C. So I personally think that Apple has said this is the future of developing software for iOS devices and for the Mac, and I think that basically means you should err on the side of Swift. Okay, so the question was, is it possible to write an iOS app entirely in Swift, 1? And 2, how about the backwards compatibility? 1, yes, it is. You can, if you open up Xcode and you create a new project, the template will say what is your default language, and you can say Swift, and every single line of code in your app can be written in Swift. I've written apps like that, a couple, and yeah, one thing I want to point out though is, I mentioned interoperability with Objective-C. You can also in your projects mix and match Objective-C. So you can have some Objective-C classes and you can have some Swift classes if you want, which is really nice if you want to start migrating an existing project. So maybe you already have a project with 100 or so Objective-C classes. You can just drop in a single Swift class and you can start working with that. There are nuances to the bridge. There's some, Swift constructs that do not map exactly to Objective-C. I mentioned that there were structs. Structs are things that cannot be, they're Swift only. So the bridge back to Objective-C can't understand your code if it's using structs. But if you use classes and you subclass from NSObject, which is the sort of root class in Objective-C, then you can have sort of seamless interoperability between the two. The other part of the question is, what about backwards compatibility? So Swift runs, natively on iOS 8. It does run on iOS 7. I'm not sure if it's iOS 7 or 7.1, but the mechanism by which it does that is that when you're building and you're saying, I want to be able to run on iOS 7 or higher, it actually bundles some of the Swift libraries right into your app's binary. And so it loads that up at runtime and it's able to execute it. Sort of along the lines of how some of the other frameworks that allow for cross-platform development bundle in all the libraries that it needs. So it'll increase the app size by a little bit, but aside from that, it should be pretty seamless. Is there another question? Is one from the audience? Right. So when I said it doesn't have dynamic dispatching, I was not complete. It does have dynamic dispatching, but that is it's absurd from the language. So the way that it works when you're bridging with Objective-C is that, as I mentioned in Objective-C, you have a method on a class, and those wind up getting called essentially by name using a dispatch table rather than like a V table that you would have in C++ or a lot of other languages. Swift behaves especially when you subclass from NSObject. Swift sort of goes into dynamic dispatch mode, where any function that you declare on your class will be dispatchable by name, so that the Objective-C code will call into that. So theoretically, there might be a little bit of a memory and performance overhead to it. I've not observed any difference in behavior, but yeah, it does sort of go into dynamic dispatch mode when you are subclassing Objective-C. So you're a little bit in Objective-C world when you're working with stuff, but mostly it's obscured from you. And similarly, Objective-C libraries very frequently do require some degree of dynamic dispatch from the client code. For example, you have action target patterns where you are specifying selectors for what happens, like when you tap a button. The only mechanism by which you can declare those is a string in Swift, which is kind of a bummer. But yeah, that uses that same selector mechanism. Does that answer your question? Yeah. Okay, very good. Yes. Yeah. So yeah, dynamic dispatch is occurring when you're inheriting from NSObject, but you don't have any of the patterns that people use where like you have an ID. There's no equivalent of an ID where you can just sort of pass any message to it or something like that, which people are using a lot when they're getting things in and out of containers that are making heavy use of duck typing, like NSArray and stuff. So yeah, I was perhaps incomplete when I said that there's no dynamic dispatching. There is, but it's not quite the part of the language that is promoted. Are there? Yes, back there. For what? No. So if you're familiar, sorry, the question was, is there any for mocking and test frameworks? The testing support right now is basically a slim port of the existing Xcode testing frameworks, which are not especially sophisticated if you've ever used them. They're basically, if you've ever used JUnit, is essentially a continuation of JUnit. So mocking is not something that is part of the language or of the developer support. However, one of the, there are a lot of sort of burgeoning Swift projects, open source projects out there, and I know a couple of them are concentrating on adopting some of these more popular test-driven frameworks that you see like in Node.js and Scala and things like that in Swift. And some of Swift's, the ability to overload operators gives you the ability to create some degree of domain-specific languages, DSLs, and one of the popular applications of that is making customizable testing frameworks. And I know there are a couple projects out there that I can look up for you if you contact me afterwards. There's a question there. Right. So the basic question. Yeah. So the basic question was, in Objective-C, as I mentioned, there's this ID type, which is like a general object type that kind of can be treated as anything, but you have to be careful because if you send an unrecognized selector to it, your whole app will crash unless you handle that. And so the questioner was asking, how do you work with those sorts of objects when you're bridging to Objective-C? So Objective-C doesn't have generics. So you have an NSArray, their core list object, and that doesn't have any mechanism of expressing the type. You just have a bunch of IDs in it. Similar for NSDictionary. Some people might refer to as a map or a hash. They just have, keys are IDs conforming to at least copying, and values are IDs. And very frequently when you're calling into Cocoa code, you get back an NSArray. And the translation into Swift is that you have an NSArray of type any object, which is their protocol that is basically doesn't declare anything, just says it could be any object. it's not that nice to deal with it. Usually, you just the quick way is to just cast it and hope that there wasn't any miscasts. You can run like filter on it. Like I was showing before, you can say, filter things out based on whether or not it is you're positive that it is of the type that you expect. But it is one of the sort of kludgy areas of interacting with things. You basically have to do a little bit of extra work to cast things. Now, some of the bridging APIs that they've written, they have narrowed down the types that it returns. And so I think in the sort of shims that they have that do the bridging, sometimes you get back like an array of strings, but most of them are just a array of any object. So it's not great. I expect that will, over coming years, that will be addressed a little better as they, work out some of the kinks in the bridge. So, are there any other questions from the audience? Oh, okay. Yep. It's not good right now. It's there's something called mirror, and as you might expect, mirror is how you reflect on things. And you can get a little bit of information out of mirror. You can get some type information and stuff. But reflection support right now is fairly weak. And that may be intentional because the language does try to guide you much more into, a statically typed, strongly typed static, direction rather than a, let's reflect on this thing and get back, figure out what to do based on what types the types hold. But it's a little bit weak. But I mean, you can, if you get an any object, you can query what kind of class it is, and then you can change your behavior based on that and decide how to cast. So. The question is it mature enough for production code? Yes, I'm writing all my new apps I'm working on, I'm writing purely in Swift. Time is extremely robust. Runtime, as I mentioned, is running on the Objective-C runtime, and that's sort of old and tried and true with its own new set of class libraries. The rough areas are really with development right now, but runtime I find to be basically as bulletproof as as the rest of if you're developing Objective-C. So I'm personally very happy with it so far. Are there any other? Yeah. So the question is, what about unit testing? Sort of going back to the question there before. There's not any really great built-in support for unit testing. Xcode itself has a testing framework that has some sort of nice reporting and stuff like that, but doesn't match the sophistication that you have right now in other languages with respect to the unit testing libraries and the sort of new patterns that you can apply to it. There are a few good, it's very new. There's obc.io. There's a web magazine called objc.io, which ironically their last issue was all about Swift. That's a very good sort of overview and introduction. There are a few GitHub projects out there, but I think the really definitive resource are at WWDC this year in 2014. Apple gave a number of talks on Swift, and they gave 3 really great talks. Beginning Swift, intermediate Swift, and advanced Swift. And you can watch all of those for free on their website, and they're highly recommended. They basically, go over the language from first principles, regardless of whether or not you're familiar with Objective-C, and they cover it really well. And they have a few examples on their website. They're posting more and more over time, but yeah, that's a good resource. Oh, and Apple published a book available both on the web on their developer page as well as in iBooks called The Swift Programming Language, and that's basically the entire manual for the programming language. A little more manually reading, but very useful as a reference. Any more questions at all? Okay. I have about 5 more minutes, so I'm going to do a very quick demo of one of the great features of Swift that that was introduced as a great learning resource, and it's called the Playground. You've probably heard of it. and so the playground is a special mode in Xcode, which is Apple's IDE, and it's a really fantastic resource for initially learning the language. It's essentially a little scratch pad where you can just kind of type, and it is executed as you type it. If I want to write my first Swift program, I can type 1 + 2, and you have 3, and that's a pretty cool thing to do. And you can do let s equals string, and then you can see on the right hand side that it's a string, and you can see that s2 equals s plus another, and you can see that you, unlike Objective-C, you have concatenation automatically in for strings, which is really nice. And you can write classes and functions and things like that. So I can do like a struct. This is how I actually wrote the framework for my tweet app. So you can say you have a struct that's a tweet, and you can say you have a var, this is username, this is string, and you have a body, and that's another string. And then you can construct the tweet. Oops, lowercase tweet, where you've got Hamlet, and the body is words, 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 worlds, worlds, worlds. So this is a fantastic resource for basically picking up the language and just sort of playing around with it without having to muck around with making a whole new project and a whole learning about Xcode project management. You can experiment with let strings equals s comma s2, and you have a couple of strings, and you can do strings dot map, and you pass in say word in. And this is our little translation thing that we wrote. And as you type, things on the right-hand side start to go gray until the compiler kind of catches up with what you're doing. Although in this case, I think I may have overcome the compiler. Oops, string. And then so like a typo, you can see error messages. So in terms of learning the language, this is a fantastic resource for just getting up and running and experimenting with syntax and seeing how some of the type inference works and things like that. So if you just download Xcode for free from the Mac App Store, you can just immediately get started by doing new playground, and it will do that for you. So with that, unless there are any other questions. Oh, okay, yeah. Okay, yeah, I can do that. I have 3 more minutes, so I can show an optional type. So yeah, the optional type is, as I mentioned, they so I like to encourage you to use non-optional types. So I have var star. I'll call it a string, even though it knows it from type inference. So now I can, I have a variable, so I can change it to bar. Or I can change it to Baz. I can change it to anything. But I can't change it to nil. Nil in Objective-C is null in every other modern language. And that's because string, by default, every type is a non-optional type. And the mechanism for making it optional is, I believe it's the same in C#, is you tack on a question mark, and that indicates that that is a nullable type. What that's doing in the backhand is actually making it a optional. There's a type called optional, and that accepts a generic parameter, and that's actually a enumeration. Let me make sure that's actually true. Yes, it is an enumeration. And with an enumeration, I mentioned you can have enumerations with associated types. So you can switch on an enumeration, and you can say case, I believe it's sum, let x, or none, which is nil. So in this case, I assigned it to nil, and the enumeration said, okay, it's a none type. But if I commented out the string equals nil, you have is a sum type. So that's a lot of sort of overhead to have just for optional types. So they have all this shorthanding where you can just say, okay, it's a string question mark, and rather than having to switch on the string, you can do this. If let, I'll say s equals str, like println s. Because if I just try to do this, you get an error saying, println string. Oh, well, println is not a good one, but let's say string plus equals x. So I'm going to get an error because I'm working on a terrible error that is a problem with Xcode. But you have an error because it's saying string question mark is not identical to, I don't know why it thinks I want it to be unsigned 8-bit integer. But what it's saying is that I don't really know how to operate on this optional type because you haven't guaranteed that it actually exists. So if I say, if I try to perform any operation on it, I need to make sure, let's let stir2 equals stir plus x. So here it's I've not guaranteed that it is optional, and there's a couple different ways to deal with it. You do this if-let syntax, which basically says, okay, within this block, s is guaranteed to be non-optional. You're doing what's called unwrapping the optional. You can also shadow the same parameter, which is sometimes nice if you want to. Shadow the same variable name, which is nice if you want to just nest your blocks of code in there that's unwrapped. Another mechanism to do that is called using an implicitly unwrapped optional, which is very dangerous, and so that's indicated by a exclamation point. So if I say, let s2 equals string plus x, I get an error. But then it says maybe you wanted to unwrap that optional and say, I really know that this exists. So continue going. And this is actually used a lot in the bridging to Objective-C because Objective-C, they make heavy use of being allowed to return nil. Very often methods return nil when something failed or something. And so a lot of the Objective-C bridging APIs have implicitly unwrapped optionals. But the downside is that if it is nil, your computer crashes with your computer. The execution crashes in often a weird place. So that's some of the danger in using implicitly wrapped optionals. So that's sort of the 3-minute introduction to how optionals work with Swift. But with that, I believe I am out of time. 11:10. So if anyone has any other questions, I'm around all day. Feel free to approach me. You can email me at mwp1 or at marc@impathic.com, and yeah, but you can't follow me on Twitter because I don't know how to use it. So thank you all very much for your time. And one more thing, please do rate this session using your GOTO app because it really helps the conference out, and it really helps me out to know what if people got everything out of it that they could have gotten out of it. So thank you again.